Now that we have the member end displacements that we calculated in the previous step, now we can substitute this back in for the member end moments. Plug away. We get the moment at the end of the left column. Plug away. We get the moment at the top of that left-hand column. Substitute in, and we get the moment at the left end of the beam. And note that these two had better be equal and opposite, because that was the basic equation that we had written. This is good confirmation that we have likely processed the work correctly. Same kind of thing for MCB and MCD. These are at that top right hand joint, equal and opposite moments there, and we get then, of course, the moment at the bottom of the right hand column. We're going to take those and then put them on individual free body diagrams of the various members, and then we can finally get reactions and all that sort of thing. Right? Now, one last little piece here that goes along with all this is that it'd be interesting to know where the points of inflection are in this particular problem, particularly because in other videos we took a look at approximating or guessing what might happen in this system. And so if we draw that free body diagram of that individual member, put the appropriate member end moment down at the column. Notice I wrote the one at the top. It should have been the one at the bottom. That's the 35.3 or 35.27 if you want to be more precise. And you got but you put those in the right way, do the sum of moments, you get the end shears. Of course, that also is our reaction there. And you take a look at what's happening here. You can say, well, alright, if I drew a shear diagram, it would be 7.25 in one direction, and then it would be uniform all the way across and close off. That the rate of change of the moment is 7.25 kip feet per feet. I need to make a change that goes a total of 35.27, hence the inflection point is at 4.86 feet, or about near the mid-height, which is a very interesting result overall and connects strongly with our guess, which our approach combined looking at gravity load analysis and the 1/10 rule that was showing up here, plus an inflection point that was only 1/3 of the way up the height of the column for gravity load alone. For the lateral load, we had effectively an inflection point that's slightly above mid-height, and we end up then with a combination of things that were very close to mid-height by the time we're done with all that. Right? One last thing to sort of point out in the reflection aspect of things, this 10 kips then turned out to not get distributed equally amongst the 7.25 or against the bottom shears, or so it seems. In reality, this is happening because of the gravity load has an impact. That in our approximate analysis we ended up with 5 and 5, but really what's happening here is the superposition of gravity load effects and the lateral load effects that creates this unequal distribution of those of that story shear to the various columns.